This is homework 3. We're going to do problem 6. Problem 6 is a graphing problem. You're given an equation, and this equation is in standard form. Negative 3x plus 2y equals 12. We say a linear equation, an equation that graphs to make a line on a coordinate grid, is in standard form when the x term and the y term are on the same side of the equation and the constant, or the plain number, is on the other side of the equation. And since it's a graphing problem, we're going to need a grid. It doesn't need to be real big. Oh, maybe a little bigger than that. And we need to recall which axis is which. This is the x-axis because it goes across, and I think of an x as a cross. This is the y-axis, and I think of that because I hold my hands up in the air with the peace sign, straight up and down, vertical, and they make a y. Alright, now we're going to talk about intercepts. We're going to be finding the x-intercept and the y-intercept using this equation. So I'm going to draw a different graph down here. Just watch, don't copy this down. And we're going to talk about what it means to be an intercept. When I make a graph of a line on a grid, most often it will cross the y-axis and the x-axis somewhere. We call those the intercepts. So I'll give you an example of that. Here's an equation, and here's its graph, its line. And this particular line crosses the x-axis here at 4, 0. That's the x value and the y value. And it crosses the y-axis here at 0, negative 2. Notice the values, the coordinate pair. For our x-intercept, the x value is a number other than 0, and the y value is 0. So when we're finding the x-intercept, the y value will always be 0, no matter where the line crosses the x-axis. All these points and the ones in between, the ones I'm marking here, they all have a y value of 0 because we don't go up at all. For instance, this one's negative 4, 0, this one's negative 3, 0, negative 2, 0, etc. All of the y values are 0. Now on the other hand, when we're looking at y-intercepts, the x value is 0 because I don't go right or left, but I do go up or down on the y-axis. So the x values are 0 for a y-intercept, and the y values are some number other than 0. So if I'm trying to find the x and y intercepts from my equation here, let's start by finding the y-intercept. I know for a y-intercept the x value is going to be 0. So what I do is I recopy the equation. I'm going to make a little note to myself. X equals 0 for a y-intercept. And I'm going to rewrite the equation to take out the x, put a pocket or a pair of parentheses in its place, and guess what I'm going to put there? X is 0. I'm then going to solve the equation. Well, negative 3 times 0 is 0. Write the rest of the equation. Don't need the 0 anymore, so I'm going to be solving this little mini equation. How do I undo 2 times y? So I get y alone. I divide by 2. And what I do on one side of an equation, I always do on the other. The 2's just make a 1, 2 divided by 2. And I have y equals 6. So I've solved this equation for x equals 0, and I found out y is 6. You've just found your y-intercept. You found out that when x is 0, y is 6. That means the graph of this equation will cross the y-axis at the point 0, 6. So I can go up to my graph and plot that point. 0 right or left for x, and up 1, 2, 3, 4, 5, 6 for y. 0, 6 is my y-intercept. Alright, we're now going to find where does the graph of this line cross the x-axis. So I'm going to write my equation down again, and now we're going to find the x x-intercept. Okay, so when we were looking at our little example here, the x-intercept is where the graph crosses the x-axis, and we found out the y value there will always be 0. So as you might guess, we're going to be putting a y in this equation that is 0. So I rewrite my equation this time. We don't know x yet, but I know I want y to be 0. So I'm replacing the y in the equation with my pocket and a 0. And now I'm going to solve this equation. Alright, I get negative 3x plus, of course, 0 equals 12. Don't need the 0 anymore, so I get this little mini equation. I have negative 3 times some number x is 12. How do I get x alone? I undo the multiplication times x by dividing by negative 3. The negative 3's make 1, so I can just cross them out. 12 divided by negative 3 is negative 4. So I've just found out when y is 0, where this graph has a 0 value y, there's an x value of negative 4. So I've found my x-intercept, and my x-intercept is negative 4 for x and 0 for y. I'm going to go back up to my grid and plot the point negative 4, 0. So from 0, I go left 1, 2, 3, 4 for the x value, and up or down 0 for y. So my x-intercept is negative 4, 0. Now, I only need 2 points to graph a line, so I can take my ruler now and connect those 2 points, extending them beyond into positive and negative infinity. And I have the graph of the equation negative 3x plus 2y equals 12 graphed by finding the y-intercept and the x-intercept. Now a shortcut, if you can remember this, when you want a shortcut, when you're finding the y-intercept, I can just cover up the x term and solve the mini equation that I get. Think about y. We put a 0 in for x. That makes that whole term go away. When I'm finding the x-intercept, I can just cover up the y term. And again, it's because I'll be putting in 0 for y. It's just going to make that whole term go away, and then I just have the mini equation with x in it to solve. That's called the cover-up method, and it's the shortcut.